I regard the results out of the ANIARA project as very important. The project's focus has really been spot on when it comes to the research that we need in our 6G network platforms. The focus of the project has been on this integrated compute coupled to AI capabilities, very key technologies. Aspects around security and sustainability has also been studied. All of this is now taking forward into our R&D work.
AI-NET ANIARA is a CELTIC-NEXT flagship project where 3 countries are involved. We have Sweden, funded by Vinnova. We have also Germany, funded by BMBF, and also UK, funded by Business UK. The project includes 20 partners, including big industries, SMEs, and academic partners and research institutes. The project started the year 2020 and ran for 4 years. Ericsson in Sweden is the main coordinator for the whole project. The ANIARA project goal is to complement the evolution of 5G with crucial technical enablers towards an intelligent and sustainable 6G platform, offering services beyond pure communication, including compute and also AI. To reach this goal, we had 5 technical work packages where VP1 focuses on use cases and demos, VP2 focus will be AI for critical services, VP3 provides platforms and enablers for distributed edge and cloud, VP4 is about proactive orchestration and resource management, and finally we have VP5 focusing on power and infrastructure edge hardware.
In Work Package 1 of the AI-NET ANIARA project, we focused on 2 key areas, smart manufacturing and smart cities. Together with our industrial partners, we looked at what's missing for them to actually utilize next-generation 5G and edge processing technologies. For example, we developed new edge processing hardware that is deployed on the Stellantis manufacturing site that helps us monitor environment parameters, but also energy consumption and machine operation. All this data is then either processed on device or transmitted wirelessly so that we can utilize advanced optimization algorithms. For example, we are optimizing the energy consumption of the paint shop.
Similarly, in smart cities, the implementation of edge computing in 5G proved essential in managing complex urban infrastructures. These integrations into different use cases marked a pivotal point in demonstrating how the cutting-edge technological integration can revolutionize urban and industrial ecosystems.
In this work package, we have developed AI technologies for automation at the edge, as well as intelligent management of resources and services. These are with the goal of improving data privacy and providing certain guarantees on the cost and performance. Examples of the technologies that we have developed are privacy-preserving distributed learning, such as federated learning, transfer learning, domain adaptation, robust reinforcement learning, and intelligent feature selection. These technologies have been developed in close collaboration with our colleagues throughout Europe, and they have further inspired research and development in our internal programs, such as 6G at Ericsson.
In ANIARA, we also look at how we can enable the edge platform to improve the deployment of distributed application. Here we focus on 2 aspects. First aspect is MLOps infrastructure for AI. Here we extended the feature store solution by ANIARA partner HopsWorks to actually allow deployment of real-time models all the way to the edge. The second aspect is related to the actual execution environment for edge applications. Here we showed the good fit of WebAssembly as an execution environment, and we actually employed that successfully in a proof point, which is a dynamic computational offloading solution. This shows a lot of promises as a future 6G service. And for this respect, it was very good to work in a project like ANIARA, because here we had the possibility to prove how this solution can actually remedy real-life issues of use cases that partners have related to both smart city and smart manufacturing.
So in WP4, what we do is we utilize machine learning for resource management. Our objective is actually try to predict and optimize the resource management in the system while trying to maintain the quality of service level that are requested. The scenario, of course, is distributed edge cloud environment where resources by definition are limited. The objective or the desire is to help have good performance and cost. So what we proposed was a modification to the Kubernetes scheduler that now is able to allocate resources based on the power consumption of node and devices. And that overall shows that it is actually able to improve the energy efficiency of the system. In the second instance, what we did was we also made a different modification to the scheduler of Kubernetes that now helps to assign resources in a way that they can be matched very closely to the time variation of the traffic. And again, in this case, we saw that we are able to improve the energy efficiency of our system by almost 30%.
In Work Package 5, our ambition has been to provide an energy-efficient, low-maintenance edge compute node that is possible to quickly deploy in an energy-scarce environment such as a city center. To achieve this, we have utilized fresh air cooling approach, where the cooling system is highly integrated in the edge node design. An intelligent power system ensures that the servers are provided with enough power also during period of limited external power supply. The edge node also includes a photovoltaic system to reduce the dependence on the grid, improve the sustainability and maximize robustness. By integrating the edge node in a fleet management system, the ANIARA solution can also contribute with energy grid flexibility services like frequency containment reserve and local peak shaving. We have successfully designed, built and operated 2 independent versions of the ANIARA edge node within the framework of the project.
We in Delta Electronics, formerly CELTIC, and our contribution in the ANIARA project has been the PSU and the UPS. So with the Rectiverter product, we have now built in new functionality in the firmware that enables us for the edge data center to support a higher peak loads than the mainstream mains connection can do. And this functionality we can now put into our production unit of both the Rectiverter and also other rectifiers, other modules we do. And that's our key takeaway from this project.
We at Qualcomm deliver AI solutions for IoT applications. ANIARA has allowed us to incorporate new connectivity and edge computing features into our current AI platform. And we've been able to demonstrate the use of these features in a traffic monitoring application. But what we see though is that the technology we developed has actually gone beyond ANIARA. And it turned out to be critical for the successful execution of several of our current customer projects. And we expect this success to continue into the future.
At Universes, we have developed a data collection system called 3D City. By installing this system in active vehicles, we can turn them into mobile data harvesters. The collected data is ingested in a tool that we have designed for cities and road authorities, helping them maintain and safeguard our roads more effectively and at a lower cost. In the ANIARA project, we have taken things a step further. We have explored how we can fine-tune the orchestration of data processing with the aim to cut costs and boost the reliability of the 3D AI City system. Through the dynamic computational offloading solution led by our ANIARA partner Ericsson, we can make sure that each device is utilized in the best way possible.